Alright, I'm going to teach you something right off the bat. So the shirt says it, school is important. If you read the fine print, muscles are importanter. That's right. Alright, so this lesson is graphing linear inequalities. We're going to graph just your basic one linear inequality. Then we're going to jump to systems of them in this video. So we're doing all the graphing. So here's your little facts about them. If you have a sign that is not equal to, so just a plain greater than or less than, we're going to draw the line dash, kind of dotted. If it is equal to, so greater than or equal to, less than or equal to, either one of those, we're pretty much going to draw a straight solid line through our points. So that's a way to check for your symbol on tests and things. So let's hop to it. Alright, first one I want to do out of these 6 examples. So right here's my little list. So we're going to graph y is less than 4. So you may remember we graphed something like y is equal to 4. It's kind of like the same thing. So at 4, we're going to put a point on the y-axis. And what kind of line did we draw before? Well, it was always 4, right? So this is going to be a horizontal line at 4. You put dots, dashes, whatever you want to put, as long as it's not connected. Okay, right there at 4. Now, here's the other new part. We have to be able to read the symbol. So y values are only going to be less than 4. So with an inequality, when we graph it, we need to shade a region. So we're either going to shade above it or below it, based off what that says. So that said less than, so we're going below it. So where are the y values less than 4? Well, here we got a y value of 3, 2, 1, all these. So everything below that line is a solution to this. Okay, everything below, we shade below it. One other thing to point out is the line itself. If it's dotted or dashed, it's not equal to, right? So if a point is actually on the line, it is not a solution. That is not a solution. Okay, if it's not equal to, then points on the line are not a solution. Okay? Let's try another one. Let's try x is greater than or equal to -1. So this was another special one we did. So we got an x to -1. And this is not affected by the y value. So x is always -1. So this is a vertical line. Since it's equal to, we can connect the dots and draw an actual solid line at x is -1. What this means also is if there's a point on the line, it's a solution. So now we read it. The x values are greater than or equal to -1. So which side of the line are the x's bigger than 1, -1, greater than? That way. So our shading will be on this side over here. So all that. So any point, anything, any of these points or values over here are solutions to this. Because at this point right here, let's use that. 1, 2, 3. The x value is 3, right? Is that x value greater than or equal to -1? Yeah. So if you ever want to check if your shading's right, you can take a point and plug it in. And that's what we're going to do here in a second. Okay, we've done those. So now we'll just create something. Make something simple to graph. 2x plus 1. So let's graph this real quick. So we start at 1, slopes up 2 over 1, 2 over 1. I'm just going to get all I can on the board. Down 2 over 1, 2 back 1. So now I'm thinking, what kind of sign do I have? I I have an equal to, so I can draw a solid line through it. So now we got a shade. So here we're trying to think, where are the y values less than this line I just drew? So where are the y values less than this line? So as I look at this line, the y values that are below it are less than down here. So I'm going to shade all this side below the line. So any pair of points in this will work in that equation. And we'll test that out in the next one since I've already erased it. Well, I can figure it out. So 2x plus 1. There we go. So let's pick a point that's in the solution area. So we got this point's in there. That is 1, 0. So I'm going to plug these numbers in and see if it's true. So the x value is 1, the y value is 0. So 0, is that less than or equal to 2 times 1 plus 1? Well, 0 less than or equal to 2 plus 1, 3. Yeah, 3 is greater than 0 and 0 is less than 3. So this is a solution because it's true when I plugged it in. It works. This is a true statement. So that tells me this is a solution. This point is. Okay, we'll try another one. Y is, let's go greater than negative x plus 5. Again, not trying to make them too tricky, so we're starting at 5. 1, 2, 3, 4, 5. Slope's a negative 1. So we're going down 1 and to the right. Why do you do that to the board? And then the other direction. Whoa! My board has clearly done something crazy here. It says text. Not know what's happening. So I see we had something like this. Y is greater than negative x plus 5. I hope that's correct. Yes. So it's not equal to, so it's going to stay a dotted or dashed line. I'm just going to kind of extend those a little bit to make it seem a little more obvious. Okay. So now we're going to focus on the shading. So y is greater than the line. So where are the y values bigger than that line? Well, these y values are smaller than the line. These are going to be above it. They're greater than the line. So that's kind of how I view this. Or you can just plug in numbers. You can always check, see if the solution is actually on that side. So let's pick an easy one right here. That's 0, 6. So I can take 0, plug it in for x. So 0 plus 5 is 5. Is that less than 6? Yes, 6 is greater than 5. So that is the solution, so I have graphed it correctly. Next slide. So now we're going to graph some systems of linear inequalities. So you've read that. We're going to have double shaded sections. So it's going to be something like this. And then this side shaded above it. And then we'll have another line drawn through there. And it's going to be shaded somewhere. So this one might be shaded below it. And then we look for the section that got shaded twice, which is right here. So my answer section would be right there. So these things are going to intersect, kind of like x's do. there's 1, 2, 3, 4 sections. Only one of them will be the solution. It's the one that gets shaded twice, where they overlap. So let's just make some up. Y is greater than or equal to 3. And then y is less than or equal to 3x minus 2. So we'll graph these, shade them, see which section is correct. Alright. So I'm going to do the bottom one first. Doesn't matter the order. So negative 2, and we're going to rise 3 over 1, 3, 1, 1, 2, 3, 1. And extend it 1, 2, 3, back 1. That tells us it's a solid line. Extend it. So now the shading part. I'm going to use 2 different colors and just take my time with it so we can see where they overlap. So y is less than the line I drew. So I'm going below that line that I drew. So below it, be down here. I'm just going to take my time so we can see this. If I use too many fingers, it gets it darker. It's kind of like double shades it. I want us to be able to see the colors. Alright. And just as a review, it's equal to, so if there's a point on the line, it would be a solution. Alright. Other one, I'm going to graph it using the blue. So y is greater than or equal to 3. So on the y-axis, we go to 3. And it's a horizontal line. And it is equal to, so it's going to be a solid line. So, looking right now, I've drawn both lines. One's already shaded. My solution is going to be one of 2 places. It's either this section here, it's already shaded, or this section up here that's already shaded. So now we've got to figure that out. Y is greater than or equal to 3. So where are they greater than 3? Above it. So if I were to shade the whole thing above it, it'd be all this. I don't care if you shade both sides or just the solution area. The actual solution would be right there that got double shaded. On any kind of test, it's probably just going to be this section shaded. That's all I'd expect to see shaded on the handout or any homework I give you. There's your solution region. Okay, we'll try another one. We won't do that many examples, we'll just do a few. So let's do y is, let's go x. X is equal to -3. That's too easy. We want to do something harder. I want you to actually think. So y is greater than 1/2 x plus 4. And y is greater than or equal to -5/3 x minus 1. Okay, let's do that one. So start at 4. 2, 3, 4. Up 1 over 2. You know this by now. I hope so at least. And it's a dashed line because it's not equal to. Okay, so now we shade. So we're greater than that line. So my y values that are greater than this line are up. So I'm going to shade this section up here. We'll just shading, we're coloring, we're having fun today. Woo. Alright, that's shading. Don't need this one anymore. Get rid of the board. Alright, so in red we graph this one. We start at -1, down 5, right 3, 4, 5, 1, 2, 3, 1, 2, 3, 4, 5, left 3, 4, 5, 1, 2, 3. This is equal to, so it's a solid line. I'm not the best at drawing straight lines. It says y is greater than, so greater than this. So where are my y values greater than this line? Above it. So above it will be this side of the line. So all this. There's your double shaded region. I don't care about shading the rest of it, but if I did, it'd be this section above it. So there is your answer region. And if we really wanted to, we could take a point in this section, whatever point we want, plug it into this equation or inequality, see if it's true, plug it into the original one, see if it's true. So you can always check your work here. That's it for graphing inequalities. Remember, school is important, but muscles are importanter.